Hey everybody, welcome to our Unit 2 review video. So instead of using the collaborate function in D2L, I've made you a review video. What I'm going to be doing is just like what I do in the collaborate sessions, where I'm going to go through the study guide and talk about the things that students usually miss or struggle with, and where you can find some of the answers from the study guide in the book so you can prepare. Let me know if you like the YouTube ones or the collaborate ones better. Let's get started. So here's our study guide. The first part is for Module 6, which was on type of research and generalizability. Remember that these parts that I've just highlighted with my mouse are the parts that are multiple choice or true and false items, and these parts, these three down here, or anything else that's after that header, are going to be the ones that are not multiple choice or not true and false. So these first ones, from what is the relationship between a population and a sample, down to what are some of the advantages of studies that are conducted in the real world, I find that students do fairly well on, again, because these are multiple choice questions and you should be able to find all of them between the text and the lecture notes. The only one that some students struggle with is this one here, as how is random sampling and random assignment different? Random sampling occurs before the study begins. It's how I get people to the study. Random assignment happens after random sampling. So I have people, and then I have different conditions. So then I would randomly assign them to those conditions. So when we think about flipping a coin to decide whether or not someone is in group A or group B, that's random assignment. Random sampling occurs before that. I also find that students do fairly well on the other questions in Module 6, the ones that are not multiple choice style questions. So this is matching types of sampling, the weird acronym that's in the lecture notes and making sure that you know what each letter stands for, and the file drawer problem. The file drawer problem, of course, is also in the textbook. So honestly, I find students do very well on the concepts from Module 6. So go back to the quizzes, make sure you look at your understanding of Module 6 and these items. If all of these items make sense to you, then you're probably in good shape for Module 6. But if not, make sure you reach out to me on the FAQ board. The next module, Module 7, is on measurements. I find that students tend to do a little bit worse on the measurements part. Particularly, can you tell the scales of measurement apart, and then differentiating between reliability and validity. So the first two items, the scales of measurement and reliability versus validity, are the ones that I find that students struggle with. The rest of them, from what is an open-ended question down to reactivity, I find that students do fairly well on. So let's talk briefly about scales of measurement. Okay, so for scales of measurement, there are 4 kinds. There is categorical. And categorical literally means categories. There is ordinal, which is about a ranked order. And then there's ratio and interval. Now the easiest one to tell apart is categorical, because we're literally making categories. And these categories have no mathematic difference between them. So it's the difference between things like red, blue, yellow, male and female, group 1 and group 2. These are just categories. Ordinal is the first time that we actually have a distance between things. But ordinal is about your ranked order. So it's second, third, fourth. And this might feel like there's an even distance between first, second, and third. But think about a race. If you have a race, the first runner to cross the finish line might finish first at, let's say, 1 minute and 38 seconds. And the next runner, the person who gets second place, might finish at 1 minute and 42 seconds. But maybe the third one finishes at 5 minutes and 3 seconds. There's not an even distance between first and second and third. So that's how we know that ordinal is not actually mathematical categories, it's just a ranking system. Then we go into ratio and interval. The way that I remember the difference between these, because these are the ones that actually do have mathematical differences between them, is that for ratio, the 0 actually means none. In ratio, The 0 is real. So the 0 means a lack of whatever it is. Whereas interval, the 0 point is actually random. It's assigned. Think about it like pant size. You can buy a size of pants at the store that is size 0. But that doesn't mean that there's a lack of pants, or there's a lack of legs, or there's a lack of body. It's just a random number that we've picked for that size. Whereas for 0, the money you use to buy the pants could actually be 0. Perhaps you have literally no money in the bank account. That 0 is real. It means a lack of money. And that's how you can tell ratio from interval. The one that I want to make sure you know the difference about is with temperature. Temperature is almost always interval, because if you think about it, 0 Fahrenheit and 0 Celsius does not mean a lack of temperature. It's usually an arbitrary point, sometimes in the relationship to the freezing point of water. The exception to that, though, is the Kelvin scale, because the Kelvin scale of temperature measurement, the 0 point on that is absolute 0. It means there is literally no temperature. It's how we measure the temperature of things like space. So Kelvin is ratio, and Fahrenheit and Celsius is interval. So the other item that we need to talk about is reliability versus validity. Some of the pages that are in the second edition of your textbook that are really useful for this are page 129 and page 146. Basically, reliability is whether or not a measurement gets consistent results, and validity is whether or not it's measuring what it's supposed to measure. But you also have to understand the relationship between validity and reliability. That to be valid, something has to be reliable. But just because it's reliable doesn't mean it's valid. You could have something that consistently measures, and by measure, I mean you get the same kinds of scores over and over again, but is poorly operationally defined and thus is not actually measuring what it's supposed to measure at all. Page 146 kind of goes into this, but if that's not clear even after you read it, make sure you reach out to me on the FAQ board. The other non-multiple choice question that's on problematic survey items, you should be able to find the answers to that between the lecture notes and the chapter. But basically, I'm going to give you a badly worded survey item, and you're going to need to identify what type of problem it has, and then talk about how we correct for that. Particularly make sure that you are aware of the difference between leading questions and double-barreled questions. The next section of the study guide is on Module 8 and on correlations, and that's the last specific module that we'll cover in Unit 2. The information on correlations also goes back to the information in Unit 1 on scatter plots. So the difference between positive associations, negative associations, no associations, those are also important again. Remember that you can make predictions from both positive associations and negative associations, because those are positive relationships and negative relationships, but you can't make predictions when there is no association. The same thing's true with correlations. If you have a positive correlation, you can make predictions. If you have a negative correlation, you can make predictions. But if there's no correlation, you can't make predictions. I find that students tend to struggle with this item, the difference between a sign and the strength of a correlation. But that from the third item on the study guide, what's the difference between a t-test and a correlation, down to mediators and moderators, that students tend to do very well on those items, again, because those are multiple choice items. So in a second, we'll make sure that we talk about this part about type of correlation and strength. For your non-multiple choice true and false items, again, I find that students do fairly well for this one, the one on the labeling of the scatter plots, because of course we did that in Unit 1. But that the other two, the part about statistical significance, positive, negative, and correlation strength, that one students struggle a little bit with. So we'll talk about that in just a second. And then also why you cannot infer causation from correlation, particularly what are the three things. For that item, on why you can't infer causation from correlation, that's a really important concept when we talk about scientific research, because many people think that just because two variables are related, that you can say that one causes the other, and you just cannot. But why can you not? I find that students who go to the book and find the three conditions that you have to have for causation answer this short answer question well. A really good page for the second edition of the textbook for this is page 222, figure 8.14, that talks about the 3 criteria for establishing causation. The first one is you have to have covariance, and that means the variables have to vary together. That's what a correlation does. It shows that these variables are related and that they vary together in this very specific relationship. But to establish causation, you need 2 more things that correlations don't have. So again, make sure you understand that there's 3 things you need for causation. Only one of those is something that a correlation does, and the correlation does not do the other 2. If you can describe that, then you'll do well on that short answer. But let's talk about correlations and their numbers to make sure you understand that concept as well. So when I'm given a correlation, let's say that 2 variables are related for positive 0.35. That one line tells me a lot of things. First of all, we have this, the sign. And the sign is either positive or negative. And again, that goes back to what type of association it is. If it's a positive relationship, as one variable increases, the other one increases. That's a positive correlation. A negative correlation is still a correlation because as one increases, the other one decreases, and that is still a relationship. The other part we have is this, and that is the strength. 0.35. Now, the first thing to understand is that correlations range between -1 and +1, and that the closer to the ones that you get, the stronger it is. So that -1 and +1 are equally strong, and that the closer to 0, the weaker it is. Correlations cannot be greater than 1. The sign tells us the type of relationship, and the number tells us how strong it is. So that something that is, let's say, a positive 8.5 is just as strong as negative 8.5, all right? And that negative 8.5 is stronger than positive 0.36. Now, usually when you're given correlation results, you're also given a p-value. And if you remember, your p-value is your probability of a type 1 error, and that if a p-value is less than 0.05, it's considered statistically significant. So if I'm given results that look like this, I've got lots of information. Again, this is a positive correlation. That is a 0.6 on strength, so stronger than it is weak. And because our p-value is less than 0.05, we know that it's statistically significant, which means it is in fact a relationship. If your p-value was something like, let's say 0.75, that would mean it's greater than 0.05, and thus it is not statistically significant. And that means it's in fact not a correlation. We can ignore it. The real key about statistical significance is that your p-value is your probability of committing a type 1 error. So the 0.05 means 5% because you move the decimal place over 2, and that's how you go from a number to a percentage. So we as a field have decided that a 5% chance of a type 1 error is as much chance as we're willing to make. So if your p-value is 0.05 or 5% or less, then you're good. But if it's more than 0.05, if it's greater than a 5% risk of a type 1 error, then that's not good. And we're going to call your results garbage, basically. They're not statistically significant, so they don't actually exist because there's too much chance of error. Now in your correlation PowerPoint, there is a whole slide that is some example results, and hopefully you can kind of use what you now know to interpret that slide. The last part of your study guide is the cumulative section. Again, matching your types of reliability and validity. Students tend to do very well on that. You can always put a post-it note in that part of your textbook. I will be asking again for you to write an operational definition for a random concept. On the Unit 1 exam, remember I gave you sleep, which was kind of me, because that was the variable that was on your PowerPoint. This time I will not be giving you sleep. So make sure you understand how to write an operational definition versus a construct or dictionary definition. We'll also be talking about the claims and how to test and critique each of them, so make sure you've reviewed that as well. And then just like the last exam, I'm going to give you a brief study, and you're going to have to talk to me about the variables. At this point, not only should you be able to tell me the difference between what is a measured or manipulated variable, and particularly which one of those are dependent or independent, but that you're also going to need to be able to write a null and a research hypothesis. We talked about that in Unit 1 as well, so again, just make sure that you revisit that. I will also be reviewing the confounds and extraneous variables, as well as the differences between qualitative and quantitative, type 1 and type 2 errors, and how to calculate your mean, medians, and modes. I also have a few more definitions on here, and that's the whole of the cumulative area. Now, there are some bonuses. As per usual, I don't answer questions about the bonus. I'm nice enough to tell you what they are, and so it's up to you to find them. But basically, the first one is if you pull up the correlation PowerPoint, there are two pictures in there that have people. One is a picture of an actual person, and one is a caricature cartoon of a person, and you just need to tell me who those people are. And then the other one is I'm going to give you an APA citation, and I'm going to make it all wonky, and your job is to fix it. Now, that's a bonus for now, but probably on the next exam, it will actually be 4 points. So this is kind of your opportunity to practice it and then hopefully get better. That's pretty much it for the Unit 2 study guide. Again, I'll be around, so make sure that you use that FAQ board before the exam starts. And like I said, feel free to let me know if you like these better than the Collaborate ones or whether or not you like the Collaborate ones better. All right, thanks.